Start.
Lift off.
There we go. Lift off. Hey, welcome everybody to Astronomy Daily Live.
Live.
It is 2 hours UTC, and it's time once again to gather together this worldwide community and think and talk all things astronomy and space and science and other nerdy things. Pretty much whatever we can come up with here. Tangents once in a while, although I'm gonna reel those in occasionally, but tangents are good because they let you sort of think outside of the box, and that to me is really important. So yeah, I hope everybody's doing well out there in the universe and the world. Things are good here. It looks like the monsoons are beginning to kick in a little bit, which is it's a little bit early for that, but the sure sign that the monsoons are here is that it is just now nothing like Louisiana, nothing at all. But here it is like wet. I can almost wring out my shirt. Right, I'm slightly exaggerating, but it's definitely humid here for sure. So yeah, I think Atta is with some students tonight. I think they were doing some things. So Atta is not going to be with us, but Bobby's here. Hey, what's up, Bobby?
All right, nothing much. Oh, yeah, it was. We had a heat wave today.
Yeah, I think that's. I actually heard that France got up to like 45.7 degrees Celsius or so, which is
Oh my.
that's really
Oh
hot.
my
That's
gosh! I didn't even look at the current. I haven't even looked at the observed data on it. But yeah,
yeah.
whenever I was walking through the other part of town, it was hot.
I'll
I
bet.
think what's good about this Ready Well, it's got a temperature thing that tells you the apparent temperature. I'm not sure you're gonna be able to see it.
Yep, we do.
All right.
73? 73,
Yeah.
is that what it said? Yeah.
Yeah.
Wow, it's cold
So,
there.
well, go in my room, but yeah.
Yeah.
But I checked it for a little while, okay, but it was getting like about like going through like 110 and stuff with the temperature of my Ready Well.
Yeah. Well, it's the season. So yeah, so hope everybody's doing well out there. I do now have a Patreon page. If you go to Cosmic Lettuce on Patreon, you can support my research. I'm doing. I've sort of accumulated a few projects that I've sort of gotten partially through. And what I'd like to do is I'd like to get through a few of these, which means I want to finish the work and I want to write a paper. And so that takes a lot of time and energy and everything else. I mean, I've talked about that. And I've been sort of plodding along with those and moving kind of slowly, but I'd really like to step on the gas there a little bit. And the way to do that is to sort of allow me to sit here and work. And if I have to sit here and work, well, the bills have to be paid somehow. So there we are. So yeah, kind of an exciting thing. I've
Yeah.
decided that
Yeah.
on two projects, and one I'm going to sort of move forward with, and so yeah. So check all that out. Um,
Yeah.
just go over to
And
Patreon.
another thing I was off to add, not only that we
Mhm.
had a heat wave, but we also had a series of storms and some rain.
Wow. Yep, tis the season. Anyway, so um, check me out on Patreon, Cosmic Lettuce. Tom over there in the chat is a patron. Thank you very much, Tom. Greatly
Yeah.
appreciated. And
Mm.
so yeah.
So
It's
what?
sort of
And there's not only just Tom, but there's also Chuck in the chat.
Yeah. Hey there, Chuck. Nice to see
Tom and
you
Chuck.
also in the chat. So Chuck and I and Jim from Carolina Sky Astronomy are just in the beginning phases of what looks like is going to be a pretty interesting musical collaboration. We're sort of working everything out at the moment, but actually, what we've got now is sounding pretty good. It's got to be tightened up and everything, and we want to mess around a little bit, but yeah, I'd like to get that done in the next week or so, and release it and see how it goes. It's sort of an astronomy related song. It's a blues song. Jim called it Cloudy Night Blues. So that's exactly what we're going to call it. It's sad, not exactly melancholy, but it's pretty sad, just like what a cloudy night should be, right? So that's a lot of fun, and so yeah, I'm sort of thinking, Chuck, in the next week we should be able to nail that down completely. So that's a lot of fun. We all three seem to be really open to all kinds of music, and so who knows? We're starting with something simple with the blues. The blues is sort of a simple thing. I mean, putting that in quotes because it's the blues allow for a lot of flexibility and freedom. So really nice. Anyway, let's get back to astronomy here. What I want to do is today is the day that the book is going to be closed on Aries, and we will move on from there. Bobby suggested that we go over to High Rise and look at some Mars stuff, and it's like that works for me. So yeah, I think probably with those two things, that'll probably fill up the hour or so. Yeah. So sit back, relax,
how
enjoy.
long did you stay on Jill's channel?
Oh, I popped on and I thought I was going to be there for just a little while, working on some things at my desk at work, and so I popped on, said hi, and then I left because I had to go do something. So I never, yeah, never.
I don't think
he
never like. There's like not much people doing digital modes unless it's FT8.
Well, I figured those kinds of things come and go. I don't know. They get popular and then they wane away.
What makes me exciting when it comes to the amateur bands is usually within the 2 meter, and well, I usually get the majority of all the activity that I've been capturing is within the 2 meter. I never captured anything on the 70 centimeter, but I've been capturing some GMRS and some other out of bands and stuff like that. There were some Cap plus DMR that's there, and so yeah.
Cool. All right. Well, let's finish Aries by going back to the galaxy that we were looking at yesterday. We sort of looked at one reference, which was Edwin Hubble's sort of first mentioning of this object back in 1926. I always like to do that. I always like to look at some of the old stuff and see how good or bad it is, right? And the work he was doing there was absolutely just awesome, just absolutely fantastic. So, but yeah, let's this object has an unusually large number of references. So I'm kind of curious as to why. I mean, it's not really in any kind of a cluster. Um, it's not part of any kind of group. It's right next to a really, really, really bright star, which, at least as far as I'm concerned, that makes it kind of hard to properly measure.
I wonder if
So
you have a kitty on the lap.
I I do not, but you that doesn't look like a kitty though. It's an awfully big one if it is.
Yeah, I have seen
uh,
bigger dogs that's like the size of a horse.
now, how old is he?
He's about we got him when we moved in 2015. We
Okay,
moved
okay,
here
so
in this house
yeah,
in 2015.
gotcha. So he's a pretty small little doggy though.
Yeah, but he sure got some big legs.
He's great. And look at
Yeah.
that long monkey tail. Look at that thing. Holy moly!
Yeah.
Wow.
And he still got his bling bling, but I'm not. But I'm not sure what my uncle wants me to do with that collar. Since it's not wearing out, but it's losing some of the black.
Oh, okay. Still looks pretty good, at least from here.
Yeah.
Yeah, what a happy doggy. Look at that. Ah,
Yeah, and what's also crazy about it, this used to be my mom's dog before she died.
oh, that's awesome. That is so awesome.
It's still
So,
my dog, though.
yeah. Well, so there's a little bit of her right there, too. So that's nice.
Yeah.
Yeah, pretty cool. Pretty cool. All right. Let us move on to NGC 821 and get this over with. Let's see. I'm really curious as to why there are so many
Uh-oh.
references. Because, like I said, it's just sort of a regular run-of-the-mill elliptical galaxy that is
Oh.
kind of challenging to observe because of this bright star next to it. So let's see if we can find out a little bit about this. Like I
Yeah.
try to say,
Now,
this
do
live
we
stream,
have an official timeline of when Hangouts on Air is supposed to be going away?
I don't, but that's actually on my list of things to start
Finding alternatives,
really,
yeah.
really diving into this weekend. It's on my list. I don't know if
Yeah.
I'll get to it, but yeah, I mean, I want to transition ASAP. So,
Yeah.
but I, it sort of sucks because these hangouts are just about perfect as far as I'm concerned. Uh, you
Yeah.
know, for the situation I'm in terms of bandwidth and computing power and all that, I can handle
Yeah.
the Hangouts.
I'm not
If
even
I
sure how good Big Movie or the one that Ron wants you to go to. I don't think it's got any mention of social media platforming.
hmm, yeah, well, I definitely want to.
I downloaded the white paper though.
Okay. Yeah, I definitely want to stay on YouTube, and I want to stay live on YouTube. So, but what that's going to look like, I'm not quite sure yet. So,
And with that said and done, what do you think are the possibilities that you might have to get yourself another computer to fit
that's
the demand?
yeah, that is definitely on the table. Yeah, we'll see
Because now
how
these days,
things go.
if you're going to be planning on streaming anything, you gotta have a good hardcore computer.
Yeah, well,
But not too hardcore. I mean, if you're not into games, then usually like let's say like mid range or something
mhm.
would be good.
Yeah. Really, my limiting factor here, beyond the computing thing, is bandwidth too. So something like OBS, I would love to use OBS, but it kills my machine, and the bandwidth is just too high. So So, but everything
Yeah.
is sort of, I'm not going to exclude anything because I can't right now, because those
Yeah.
kinds of things can be dealt with.
If
So we
we
will
could
see.
find something that is like low resource, low bandwidth, I think we're good, right?
Yeah, like Google Hangouts. Yeah.
And Uncle Bill Duran did say about the possibility of Zoom also going out as well.
Oh wow. Okay. So
Well, it's
here,
not going out, but YouTube's gonna be blocked on Zoom.
right. Wow. All right. So here is something interesting, and actually something that I pointed out when we were looking at the image of the galaxy before. These faint but sort of, yeah, these are probably foreground stars, but they could be globular clusters associated with the galaxy. Can't be exactly sure, but there's a paper here. Where was it? That was talking about a catalog of over 4,000 globular cluster um,
Yeah,
um, radial
yeah.
um, velocities
And
in
we like to
27.
welcome Andy Calloway in the chat and Uncle Bill. You said on the Discord one time that once Hangouts goes off the air, there's a possibility that Google will block Zoom from YouTube. Uh, if I recall correctly.
Okay, yeah, let's see if Uncle Bill has anything to say about that. Andy, nice to see you in the chat again. Great to have you here. I think Andy's one of our UK folks, right? So it's early in the morning over there. All right, well, let's take a look
Yeah.
at this one. This is a
I
pretty,
think truth to be told is 3:17 a.m.
yes,
British summertime.
yes, correct, correct. So let's take a look at this thing. It's called slugs, Sluggs. So I'm kind of curious to know what that
Uh,
stands for. But yeah,
mm,
so let's take a look here.
all
They're
right.
they're they're
Yeah, anything
obviously
is possible, but and he also puts nothing beyond Google.
yeah, yeah. So they've obviously been looking at quite a few globulars in some galaxies. So I'm thinking, I don't know, and I don't think elliptical galaxies are characterized as early types. So ellipticals, I think, are considered pretty old objects. So well, we'll see if NGC 821 is in here, and even if it isn't, we'll still probably find something moderately interesting here. The slug survey. I want to know what slugs stands for first, but let's see what we've got here. Australia, United States, UK, cool. Italy, nice, nice. So that, I always like to see collaborations around the world like this. It just makes for a long list of authors, but that's okay.
Eh,
So let's see. Beyond the local group, blah, 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 blah. What is slugs? Where is slugs? Oh, see, they mention it here, but they don't say what the acronym is. They don't say it up here either. Oh, man.
The
Some people.
Sages Legacy Unifying Globulars and Galaxies Survey.
Oh, okay. Who found that?
That would be Page
Page
Master.
Master.
Your
Cool.
favorite captain
The
is not
sages.
here, Page Master, so sorry.
Yeah. Atta is out with her kids tonight, I think, doing something. So the
Yeah.
Sage's legacy, unifying
I
globulars and
didn't know
galaxies.
anything
Okay.
about it and stuff like that, but I couldn't recall. But though, yeah.
Okay. Well, let's do the simple thing and just search for 821. Ooh, there it is. Hey. Uh, so
Eh,
let's so let's see if we can, these are just the properties of the galaxy, but sometimes that's kind of interesting too. So they're saying and I don't know if they're saying this or if they're getting this probably, yeah, they're getting all this information from others. So
Okay,
they,
so Page Master has the home page procedures.
oh, cool, nice, thank you.
So the Sages Network exists to investigate the formation and evolution of our government customers and their host galaxies with a focus on using the world's best observational facilities, including HST, Keck, BLT, and Subaru, to provide flash crews. Our current emphasis is on pioneering systematic chemodynamical surveys of Uri-type galaxies, ellipticals, and ledicurs.
Hmm, nice. All right, well let's just get some
And
basic
that was from the Sages homepage.
from the homepage. Cool, nice. Well, thanks for that link, Page Master. That's very cool. So it says it's 23.4 megaparsecs away. So 3.26 million times 23.4. So they've got a distance of like 76 million light years. So okay, that makes sense. This log M star, that's the mass of the galaxy in terms of solar masses, and it's a logarithmic scale. So it's basically 10 to the 11th solar masses. So that is a lot. That's 100 billion, right? That's 100 billion. Yep. It's 100 billion solar masses. Now, that doesn't mean that there's 100 billion stars, because not every star is the mass of our sun. Sometimes they're smaller, and sometimes they're bigger. But solar mass is what seems to be kind of average. So now that doesn't mean that it's the median. That half the stars are larger and half the stars are smaller. I'm not exactly sure where that goes, but in terms of mass, they're talking about 100 billion solar masses. So that's that's quite a few stars. R sub e in arc seconds. I'm not quite sure what that is. Environment, distance, seismic velocity. I'm not quite sure what that is. I don't know what R sub E is. Environment? Yeah, I'm not sure what that is. They're calling it an E6, which I think is what Sinbad has it. Oh, okay, here's the environment. I'm not quite sure what F means. We might be able to find that out. Distance, morphology, environment, galaxy, seismic, stellar masses, and effective radii. This is probably, yes, it's an effective radius. So in arc seconds. So that's just the size, like the apparent size of the galaxy as we see it. Yes. So 43.2 arc seconds. Yeah. Okay. Galaxy type, E6. Yeah. So there's a systemic velocity and then a velocity dispersion. So here is the radial velocity. It's moving away from us at 1718 kilometers per second. But there's a dispersion of that. So what this number is saying is that the velocity is 1718, sort of plus or minus 193 kilometers per second. So that's kind of interesting. They can sort of look at different parts of the galaxy and measure the velocities there too, and get that. And you can sort of see there's a pretty decent spread here. Some of these guys, let's see, all the ellipticals. Yeah, it's kind of hard to tell looking at this, but yeah, there's a pretty good spread there. So, all right. So that's sort of the basic info about 821. Let's see if there's anything else. It looks like there might be. We tabulate the objects we identify as UCDs in Table 4 for the Galaxies NGC 8. Okay, so they're calling this an ultra-compact dwarf. Ultra-compact dwarf. Okay. All right. Works for me. 821. Globular system, or globular cluster system catalog properties. So if I'm interpreting this right, I think it looks like they're counting about 68. They've observed 68 globular clusters in this. I'm not quite sure what the rest of this is. This might be some kind of an exposure time, the amount of time that they spent looking at this object. I'm kind of curious to go over. I was actually looking at these ARP galaxies just before the live stream, so I've still got them on here. But let's go over to HST and see if since I think Slugs, the description, Bobby, that you read, I think they mentioned HST. So
yes,
let's see. Yeah, so let's see if it's there. Should be, I would think. I'm going to blow this up a little bit just so you can see a little bit better. So we'll just grab anything that the HST has done with that. So, yep, we're ready to go.
Engage.
Shouldn't engage. Oh, yeah. So, not a lot, but enough to keep us satisfied. Oh, wow. So really hasn't been observed since 1998. That's kind of interesting.
And when was that paper?
This is like 2018 or 2019. So yeah, I mean well, let's take a look here. Oh, here's NGC 821. Let's see, what is this? So this is the velocity versus radius. So probably going from the center of the galaxy out, and they're just looking at the velocities. Probably, yeah, these are the velocities of the globular clusters that are going to be associated with this galaxy. So they've identified quite a few there. That's kind of neat. I think they set up here what there were 68 of them. Wow. Okay. Well, if any instrument can see them, HST certainly can. So it looks like they were using NICMOS for this stuff. Well, at least a little bit of this stuff back in 19 98. So that's an infrared instrument, not too high res or anything. So I'm not expecting much here, but let's take a look anyway. Let's see, so as you can see, these numbers are in angstroms. So this is very, very much in the infrared. That's 1.6 micron. So yeah, let's take a look here. Relatively long exposure, 639 seconds. Pretty long. That's a little over 10 minutes on each exposure. It looks like they took 3 of them. Now, what's kind of interesting to me here is that these are all at the same time. So, 3 different apertures. I'm not quite sure what this is, what the apertures are there. As I said, this live stream does not really give you any answers. It just gives you more questions. So what are these? I don't know. But let's take a look. Maybe we'll be able to find out just by looking at the pictures. So this is NIC2-fix, whatever that means. Well, that definitely looks like some kind of elliptical something. But, pretty low res. I don't know if I'm necessarily seeing any details in here. Now, these are JPEGs, so the quality isn't going to be incredibly great. I can try to zoom in a little bit here with the screen. I'm seeing things in here.
Now, can you do some colorization with those 3 images, or you can't?
Well, these 3 images were taken at exactly the same wavelength, exactly the same exposure time, and exactly the same instrument. Let's sort of see if we can tell what the difference is between this, which they're calling NIC2. Let's look at NIC1 and see if there's a difference. So we've got to kind of remember that because it's going to override it here. But oh wow, that's really different. Okay. So definitely not really sure what we're seeing here, but it is what it is, I suppose. That's a lot different than what I expected. Ooh, so these look out of focus to me. They look like little donuts. Wow.
Yeah. And they're trying to get 3 in a row with that?
Yeah. I mean, let's look at the proposal abstract here and see if we can. So they're trying to do broadband imaging. Since almost all their type galaxies are with dust, these images, which are less
now, they
sensitive to
did say
extinction.
they also use different telescopes in the SAGES.
Yeah, but this is all HST data, right? All this, this is coming from the HST site. So you're exactly right. This survey is utilizing other resources, but what we are looking at here is just HST, just pure HST.
Yeah.
Starter population gradients. Well, I'm not seeing anything totally clear here, but yeah, okay.
No.
We're just looking. Let's see. STIS, I believe, is more of an imaging system. Oh no, I guess it's a spectrometer. Okay, so these are just going to be spectra. You can sort of see the wavelength range we're looking at here. Very, very, very red. This is well beyond the sensitivity of our eyes. That's very infrared. It's not extremely infrared, but 8,300 angstroms to 8,800 angstroms. And,
And the STIS is more the spectrometer, right?
I believe it's a spectrometer, yes. Yes. And that's exactly what we're looking at here is a spectrum of this galaxy. And believe it or not, pretty much every single wiggle in here has some kind of interesting meaning.
Alert! Alert! Alert!
Alert! Hey there, Ron. How are you?
Hey, how you doing?
Good. We're looking at some.
The best looking one in the group.
What's that?
Where's the best looking one in the group?
She's out with the kids tonight.
Funny how you do that.
Yeah.
Bobby,
She's out with the kids.
All right, cool.
So we are trying to wrap up the constellation Aries finally, and
Okay.
not that there's any kind of rush or anything, but I don't know about you, but I'm sort of getting tired of it. So so we are looking at sort of
What's on your calendar after that?
so this is a spectrum of NGC 821 as seen with the Hubble Space Telescope. So yeah, I mean, it's just what looks like a bunch of wiggly lines is actually quite a bit of information. I would say that most of these wiggles, and especially the big ones here, are showing off some kind of emission from some kind of either a molecule or some kind of element or something. Not exactly sure. We're just looking at the data, right? So there's really no interpretation here. But let's keep going here a little bit. Let's see if this is probably also a spectrum.
In a literal sense, everything has a frequency. In a literal sense, everything has a frequency of some sort.
Well, I would say that everything has a resonant frequency. So and that's what we're seeing here is that these atoms and molecules are vibrating in a particular way that is sort of allowing them to emit light at very specific wavelengths, and that's what these emission lines are here. So, but spectroscopy gets complicated really, really, really fast. So I'm not even going to try, to try to interpret this. But there are some structures in here that probably indicate the presence of some kind of stuff, right? So let's see. Let's looks like, let's see. So they were looking at things with a spectrometer in like September of '98. Is this the same group? Yeah. So the same group was also there October of '97, also using STIS. So my guess is that this is going to be a spectrum too. Yep. Okay, so not the most exciting thing in the world. Here's a WIFPIC 2. So here's an actual image. So we'll be able to actually see what these guys are looking at. So this is back in January '96. 350-second exposure with PIC 2, which is the wide field planetary camera number 2. And it looks like they were doing multiple exposures at least a couple of different wavelengths here. Let's see if they got any more. Nope. It looks like they were just looking at about 5439 angstroms, and then again 8012 angstroms. So this is sort of right in the middle of the visible spectrum, and this is really, really, really red. That's almost beyond what we can see. It's almost infrared, almost. So, but yeah, let's take a look. The name sort of implies that they are looking at the nucleus of this thing. So let's see what it looks like. Here it is. Okay. Well, it is one of these elliptical galaxies. So there's almost no gas and dust, anything else, and it looks to me like a lot of what we're seeing here is some noise, lots of cosmic rays. Let's see if we can zoom in a little bit. So all these little lines here, those are cosmic rays. Those are some kind of energetic particle. They can be protons. They can be just all kinds of things that just smash into the camera, and they make a little line. These dots are probably bad pixels, probably. But I'm also seeing these little faint fuzzy things all around here. And what I want to say is that those are probably either foreground stars, stars that are just within the field of view, their line of sight, but they're in our galaxy, or they might be some of these globular clusters, especially the ones that are relatively close in here. Kind of hard to see.
So now
this is a different image, right?
I don't know what you mean by different, Bobby.
Yeah, I'm talking about in different exposures, different wavelength.
Well, this is the one. I'm pretty sure. Whoa.
So now the question I had was, when you look at something like that, what are you looking at? Are we as earthbound around our backyard astronomers? Are we just looking at to see if we can find it? We don't really see a whole lot from our backyard.
Yeah, I mean,
what are we actually looking for? Are we just saying, okay, there it is, and then move on to the next one, or what exactly are we trying to accomplish by looking at something like that from earthbound?
It's probably the best way to answer that is to look at the proposal abstract and see why these folks wanted to look at it. So let's take a look.
That's a fair question,
Yeah. Let's see, the identification of massive black holes.
A lot of us look at the night sky for any number of reasons.
Oh yeah. No, I mean, you don't observe objects with the HST just because you sort of want to. There's always some kind of reason. They are looking for a particular thing, or there's some kind of unusual activity.
Right.
There's a whole bunch of different reasons. We are looking at it here and now because it's NGC 821, and that's what we're looking at. So it's just here it's more of just a curiosity thing. We're just sort of looking around a little bit. So no particular reason. We're just having fun.
All right.
So it's sort of looking like these folks were trying to understand some properties of black holes, et cetera.
So It must have had some energy readings or something at that point.
Yeah, well, the assumption is that there is a black hole in the center of every galaxy. Now, whether that's
Mhm.
true or not, who knows? Um, but they need to look, and they need to make their measurements. I don't know if they were doing any kind of spectroscopy on this or anything, but it's a
You'd
nice.
almost you'd have to assume that something that much gravity, as black hole, for instance, would be able to hold the galaxy together, so to speak.
Yeah, well, there is definitely for sure something interesting going on at the centers of all
Of
galaxies.
the galaxy, yeah.
Um, you know what exactly that is and what the mechanisms are and what's going on. Nobody knows. Nobody knows.
Yeah.
Not yet.
All right.
Not yet. So okay, well these guys were definitely not looking for globular clusters. These guys were using this data to look for something completely different. So, so yeah, it's kind of interesting. I guess my guess is that these authors didn't necessarily use HST to identify these globulars here. They probably used Keck or one of the other um, ground-based telescopes that they have access to.
Mhm.
So, all right, well, that's cool. So that's kind of nice that and kind of amazing that they are identifying, positively identifying, um, lots of globular clusters. I think the Milky Way galaxy, and maybe somebody in the chat, Page Master or Tom or Uncle Bill or somebody, um, uh, I think that there's at least some kind of a relatively good guess as to how many globular clusters the Milky Way has. And I want to say that there's a couple hundred, at least a couple hundred. But if anybody in the chat wants to
Oh,
look
that's
that up,
total amount for the Milky Way?
yeah, I want to say that there's probably
But that's
about
total
that.
amount of that's probably total amount of what we can see.
Correct,
There might
yeah.
be
Which
more that we don't even get through.
there might, there might be a few that are being obscured by, the disk of the galaxy itself, but I think we got a pretty good handle on all those. So,
Yeah.
and like I was saying, I think there's a couple of hundred. So, the fact that they're seeing 68 here, that well, compared to us, that's a little bit low. So, is that all of them here? Probably not. I mean, this thing is what, 75 million light years away. So it's kind of hard to see, globular clusters that far away. Yeah,
Right.
I mean, it's kind of hard enough to see them, here, right? Within our galaxy, they're pretty hard to see anyway. So when you stretch them out to 75 million light years, it's getting a little hard, to see those. But um, if this is the actual number, then compared to us, that's a little bit low.
Mhm.
Here's one here that is 374 clusters. So quite a big difference there. Pretty neat. So
That
yeah,
is
slugs, kind of funny. These acronyms are great. Okay, yeah. So this is just showing the sort of the positions and the motions of those identified globular clusters. So pretty cool. All right, let's
okay.
let's keep moving here. Chugga, 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 chugga. I'm gonna get rid of all these windows here. There we go. Go back over here. Take a look at this. Okay, so that's where we were. Let's keep going here a little bit. Okay, so it looks like Chandra did some kind of a catalog. Chandra is a X-ray observatory in orbit. So they probably looked at this thing. Wonder. All right, let's take a look here. I can't stand it. Gotta look. It'd be interesting to see if there's any kind of X-ray image of sorts. Grab the PDF file here. Chandra survey of nearby galaxies, the catalog. So it looks like all those names look Chinese to me. Let's see. Yeah. Sweet. Okay. So let's see. So yeah, they okay. Oh, okay. So they were actually just looking at the public archive and trying to find these things. So they didn't even collect any of their own data. I love it. Let's see if they've got any moderately interesting images or plots here. I'm gonna fly through this a little fast, I guess. Not on purpose, but okay, so they, yeah, okay, keep going here. Emission lines. Okay, that's not incredibly interesting. You know, we need to look for 821. Uh-oh, I'm not seeing any reference to the number 821. So it might be a little obscure. Might be a little obscure. AGN is active galactic nucleus. So that just, you know, they're like we were just talking about. There's something interesting going on inside of the nuclei of galaxies, and some galaxies, the nuclei are very, very active in that they are either emitting a lot of high energy light, you know, like a lot of X-rays, you know, or something else is going on there. So that's just what an AGN is, as you see that. So but I want pictures. What are my pictures? These are all spectra. I don't want spectra. I want pictures. I don't know. I don't remember if our NGC 821 has any of these IC objects. Let's suppose we can go look. Let's see here. They always have a bunch of different names. I don't see any IC numbers. There's a UGC 1631. Nope. There's an ESO. Yeah, huh? Yeah. I don't know if we're gonna see this guy in here. I'm not really not really seeing anything here. Here again, we've got a list, but I'm certainly not seeing 821 in there anywhere. I don't think it's any of these. MCG. Do you have any MCGs here? Oh, there is one. MCG 2634. Oh. Is there some NGCs up here? $334.64. So definitely not.
In the northern hemisphere, how many are we looking at? I think we got like I a handful, I think, right?
Of what?
Basically, of globular.
In the northern hemisphere? Oh, there's dozens.
Oh, okay.
Dozens that you can see in a telescope, small telescope. Oh yeah, heck yeah. Go out and your next clear night, you should be able to go out. You should be able to see M13 up there in constellation Hercules. That's a great one. M5 is another nice one that is usually ignored, and I actually like M5 much more than M13. So take a look at M5. Yeah, I'm not seeing.
Yeah, one time I looked at the
890.
M13, it was to me, maybe it was my scope, I don't know, but it looked like it was a blue snowball. Is that right?
That sounds about right. Yeah.
Yeah.
Kind of fuzzy.
Or
Fuzzy.
yeah.
Yeah.
Snowball, or
There you go.
yeah, and actually with what I had the Celestron Ultima 2000 then, and that was your beginnings of your go-to scope.
Right.
Okay. So you were able to align it. Then you had to align it to the north, and you had to align it to 3-pointer stars, and then you could punch in your keypad where you wanted to go, and it would go right to it. It was amazing at that time, 1999.
Oh yeah. Yeah. Yep.
You could just, I mean, I think it had a 30,000 library, 30,000 item library, plus you could add 10,000 of your own personal favorites, So
But
that was pretty expensive in that time,
Yeah.
Of course, then it didn't have any of the Wi-Fi stuff. You had to, connect it directly to your computer if you wanted to see anything.
Right.
So
And
it wasn't all the fun way up today.
Yeah. GoTo is really, really great and really, really convenient. But I always encourage everyone to don't be tempted by the GoTo. Try to find these things on your own, and that's harder. It is very frustrating, but you'll get a little bit more satisfaction with your observations that way, and you'll learn the sky really, really,
Exactly.
really well.
That's what I was
Really,
gonna get
really, really well.
When you get to the point where you can kind of know your way around, wherever you are on the planet, pretty much you're gonna be able to find your way home,
Yep. No, this, that kind of thing is a commitment too. It's a multi-year commitment.
Oh yeah. It's
not anything that you're gonna learn fast. No, absolutely not. And these days it's so tempting to just push the button. And go, and that that is extremely satisfying too, because if you just want to look, if you just want to see the object that you're interested in, then that is a very satisfying way of doing that.
That's why I was asking you about Altair the other night when I was asking you about the night.
Yeah, it's great.
Yeah, anybody can figure out night sky, but when I was trying to recall it from what I was looking at, physically looking at, and I was trying to direct you in the correct direction on what I was talking about, which I did, because you were able to find Altair, like I said.
Right.
So that was pretty good.
Yeah. No, you're coming along just fine, and I mean you've been doing this a long time.
I kind of know the names and stuff already, so that helps.
Yeah.
But just to be able to describe it to somebody, in the sky.
Nope, you did good. So, yeah, the only thing I would say in your description is try when you're sort of giving directions. do like a north, south, east, west thing,
Oh yeah.
not up, down, left, right.
Where I was talking about from Vega, then Altair would be basically east, right? Southeast,
from
maybe.
yeah, I mean
From Vega.
Yeah, from Vega, Altair is pretty much southeast, correct? Yeah, it's south and to the east of Vega. Right. Yep.
Yeah.
You got it. You got it.
Good.
You got it, dude.
All right.
Let's.
I'll work on it.
Yeah, it's a long process, especially for somebody like me who's incredibly dense, and it takes a million years to figure out things. It's I mean, it took me years and years and years and years and years and years to figure all this out.
When I'm telling a story on the radio, I'll be talking about going down this road, and I'll say on the left or the right. Well, nobody knows where the left or the right of that road is. What are you talking about? Which way are you going? You're going south. Which way you headed? Then you can say to the whatever direction you want on the side of the road. You say left or the right, you can't tell what you're talking about.
Right. Yep.
So it's always better if you can get the right navigational directions.
Yeah.
And then that kind of paint the picture in the people's head.
Exactly.
I'm working on that. So I got to work on doing that a little bit better.
That's it. Just make the goal to be better every single time, and that's exactly what's going to happen. So yeah, here they're just measuring velocities as a function of radius here, so that's kind of neat.
Oh
yeah. Let's see. I'm looking at the time too, and I'm noticing that we're already at 3:02. It just goes by way too fast. That is a very clear indication that this is just way too much fun.
Oh yeah.
So I'm not going to dive into this too much, but this is an actual study of the galaxy itself. So I'd like to look at this in a little bit more.
Nice thing about being here every night is you can kind of catch up on what you left off on.
Yeah, and it can be relaxed. I don't have, there's no hurry here. There's no, I have to talk about this and this and this and this and this. It's like, no. We just do whatever we want.
That's what I like about my little radio interview I'm going to have with my friend Alan tomorrow. On my station. Alan has his own broadcast that he does on KGRA radio.
Oh, nice.
And he has a show on Tuesday night called Paranormal Now. He studies paranormal, and he might look into UFOs, but he's more paranormal type studies. Ghosts and things like that.
Yeah.
And so anyway, he's going to be a guest on my station on tomorrow, Saturday.
Right.
At 2 p.m. Eastern. So if you're available and you want to listen in and have some fun, and if you've got any questions for a guy that studies paranormal stuff, that might be a good one for you to listen to.
What time was that again?
Alan,
what time was that again, Ron?
That'd be at 2 p.m. Eastern.
2 p.m. Eastern.
So,
okay, cool. Yeah.
Charles, Bobby knows Charles. Charles was in here a couple times. Charles.
Oh, Charles, yes. I'm actually looking forward to having him.
He will actually be my co-host on the show tomorrow. So.
Oh, sweet. Yeah,
he kind of keeps me straight and on the level, so that I don't get rambling on too much about stuff.
Good. Well, somebody's got to keep you straight.
That's right. But yeah. Alan, I met Alan at Pine Bush, met him really briefly and said hello to him and got to see who he was, and a really nice guy. And
nice.
What my goal on Saturday, though, pretty much for some of these hosts that have their own shows, a lot of times on their show, they don't have the opportunity to really get into detail about stuff.
Mm.
And part of my goal on my show is to give them that opportunity. You know, if they want to speak out a little bit more about some details they weren't able to necessarily because of time
Right.
wise, you know.
Dive a little
On
deep.
Yeah.
on my show there's not going to be any time restriction
Yeah.
unless they
It,
want to have a
all
time
right.
restriction.
So, Ron, I have a question for you. Do you have the travel channel with your cable subscription, or what? Or what kind of service you got on your TV?
On my I have direct TV for my TV.
Okay.
For
To
my internet I have CenturyLink.
to travel. Yeah. Okay. I don't care about the internet and stuff. But what I'm worried about is what kind of television service you got. So DirecTV.
Yeah,
Okay.
yeah.
So in about 54 minutes, tune to the travel channel for Ghosts of Morgan City. They have a paranormal team already en route, and they're
Oh wow.
investigating paranormal activity all throughout the parish where I'm at, which is St. Mary, Louisiana.
Oh, cool.
What channel was that on, do you think?
It's
You
on the
said
Travel
channel,
Channel.
but I'll have to look that up and see which one that is for DirecTV. They got different ones. So I'll have to check what that one is. All right, cool.
All right, well,
But yeah,
awesome.
so and I don't know if you know, I had a Carol. I always call her Carol Carly, and then she made fun of me when I said that. And then but her name is Carley, so you can see why I would want to say it like that. But her name is Carol, and then she made a joke with me though. She said, "Oh, then I'll just be calling myself Carly Carly or something like that." Pretty fun. So anyway, she has her own. She was doing the paranormal news on KGRA radio for a long time, and now she's coming back and she has her own show again on KGRA radio, starting I think on July 12th or something like that. But we have been chatting back and forth, and she is really interested in having another sideline show on my channel, on my station.
Cool.
So she's very knowledgeable in paranormal news and all kinds of different things. Not just paranormal stuff. I mean, she really has got her education on some of this stuff, you know. So
Nice.
she'll be a regular guest hopefully soon. That's after she gets settled in on her new time slot where she's at.
Very
So,
cool.
but she has agreed to help out and be part of the uh, you know schedule that I want. You know,
Yeah,
again,
nice.
that would be something that she can get into and talk about things that she wants to talk about, not any kind of format. You know
Mhm.
that anyone has some. You know, you got to do this and say this and talk about that. No, I want them to be open and be a little bit more free spirit. You know.
Sure.
And
Sure.
it'll make it more interesting. You'll be able to see more of who they are. That's what I want. You know.
Nice.
All right.
I
Yeah.
So
was
just keep
noticing.
that in mind. Keep
Cool.
those open and keep a lookout for that stuff on Earth
Yeah.
Radio.
Excellent. I was noticing
And you
that
were there today.
Tom had
Yeah.
mentioned that on this day in 1911, there was a pretty large meteorite that fell. Looks like it broke up into pieces. Um, Landed on a dog and vaporized it. That's a little weird because usually meteorites, um,
Yeah.
they get
I
pretty
just had to
hot.
refresh it as well.
They
But
get
Page
this.
Master said at July 9th, Saturn will be at opposition with the rings tilted towards Earth.
Yeah, that will be a nice day. The opposition of Saturn. We just had an opposition of Jupiter a couple of weeks ago, and now it's the opposition of Saturn. So that's very cool. The thing about meteors, though, is that they're really hot way up, but they slow down, and as they come in, they cool down. Um, so Yeah, I don't know about a vaporizing dog. Yeah, I would say that is kind of a funky thing, because by the time those things actually hit the ground, they're pretty cooled off.
That's one of those Germany or Florida questions.
Must be.
That little showcase. Germany
Yeah.
or Florida, and you can find out where the story came from.
There you go. All right. Well, I'm looking at the time. It is 3:10. I think I'm going to get on out of here for today. We will pick it up again tomorrow. We didn't get to high rise, so let's kind of plan on doing a high rise show tomorrow, and we'll look at Mars for an hour or so, and Mars is, well, it's pretty much as amazing as everywhere else. But we've got some nice high-res images of that. So let's take a look at that tomorrow. I will definitely try to remember. Shouldn't be too hard to remember that. So, okay, everybody, I'm going to get out of here for now. Make sure to share this around. Tell a friend.
Yeah.
Pointing at everybody. There you go.
Tell a friend. And all right, I will be back here again tomorrow, 2 hours UTC, more astronomy, more space, more lots and lots of things. The universe is what we're talking about here. So all right, everybody, take care. Have a great evening, great day. Make sure to subscribe, thumbs up if you wish. As I said, I've got a Patreon now, Cosmic Lettuce. You can go over there and support my research. It really has nothing to do with this live stream at all. This live stream is fun. Research is WORK. It's one of those 4-letter words. But that's pretty fun too. But so yeah, if you'd like to support my work over there, you can see what's going on over there too. Just go over to Patreon and look for Cosmic Lettuce, and I should pop up there. So, okay, everybody, peace, cheers, and all that. Live long and prosper, and I will see you in just one spin. All right, see you later, everybody. Bye.
All right.